Welcome to How Angular Works. I guess I don't need as much of an introduction since I just got such a great one. But I'm Erickson. I'm the tech lead for Angular's framework team. And as she said, I work day to day on the Ivy runtime. So I spend a lot of time thinking about how Angular works. And that's what we're talking about today. So when you're building an application with the framework, it can sometimes be kind of hard to imagine what the framework is doing under the hood. But by the end of this talk, I want you to be able to visualize kind of how your application code and the Angular framework code are working together. So just to jump right in, Angular broadly has two parts. There's the Angular compiler, which is our build time utility, and the Angular runtime. And that's the framework code that ships with your application and actually runs in the browser. Today, we're going to focus on the runtime portion. But if you're interested in how the compiler works, I'd highly recommend checking out Alex's talk from yesterday. It should be on YouTube soon, and the slides are also linked in my presentation. But for our purposes today, all you need to know about the Angular compiler is that in addition to downleveling your TypeScript to JavaScript, it also parses your Angular decorators and your templates, and it generates some code that the runtime can understand. So if we take a look at this component example, we have an add component decorator like you'd write in your application. What the compiler would do is it would take this information and it turns it into something that we call a component definition or a component def. And this contains all the same information, but just transformed into something that the runtime can actually use. So one way to think about it would be that the compiler generates these definitions and these instructions, and the runtime actually implements those instructions to actually run as your application is running. So this definition probably looks kind of intense right now. There's a lot of stuff going on, but don't worry about understanding what's in it right this second. Throughout the course of the talk, I'll be explaining what these instructions are and how they work. So hopefully by the end of this talk, you can read these with confidence and happiness. OK, so when an application bootstraps, there's three main phases that it goes through. There's module setup, and this is where the framework is instantiating your modules. It's setting up the module injector. There's view creation, when we're actually creating the DOM for your entire application, instantiating directives, that kind of thing. And then there's change detection, and this is when we're checking your binding values and updating them if necessary. The first part is really the module bootstrap part of application bootstrap, and the second two parts are more related to the component tree. And today we're going to talk only about the component bootstrap portion, just for time purposes, but can always answer questions about module bootstrap after. So in the course of explaining how all this works, we have an example application that we're going to be going through. And this is my cat's personal website, or what I imagine it would look like. And so it has an image of my cat on the left. There's a header. There's an info card on the right that has all his information. And then there's a footer component that's actually scrolled beneath this viewport that's his contact information. So that's the app that we'll be using. And you could imagine its code might look something like this. It has an app module. It has a few components. There's one for the root component. There's an info card component, and then there's a footer component. And then in the root component template, you can see some of the things that I just showed you. Right? There's the image of the cat. There's the header. There's the info card, and there's the footer. So when we bootstrap this application, we're going to start with whatever component you put in the bootstrap property of your ng module. So the framework will start looking at app component. And there's a few special things that we have to do at the very beginning to set up your root component. The first thing that we need to do is locate your root element. So when you wrote your index.html, you added some tag, right, like app root, and then it should match whatever selector that you have in your root component. So the framework needs to figure out where this element is so it can bootstrap your Angular application inside it and append all the elements to it. So when you compile this component, the selector gets compiled into the definition, so we still have that information. So the framework just takes this selector from your component definition and document.query selector, that selector, and that's how we can locate the root elements. That's pretty straightforward. Next, we want to actually create an instance of your root component. And again, this is something that the component definition makes pretty simple. The compiler generates a factory function that tells us how to correctly create this component with any dependencies that it may have. So in this case, there's no dependencies, so it's pretty straightforward. You're just newing it. But we just call the factory function to get that started. And then we're ready to actually start rendering the root component. And this is where it starts to get interesting. So view creation. So we're starting the process of creating the DOM and instantiating directives. And this is where the template function comes in. So you'll recall that your HTML template is turned into a function. So all you need to do, or all the framework needs to do, is invoke this template function and give it a particular mode, so in this case, creation mode. And as soon as that function is invoked, it will create the DOM correctly for that component. So if you imagine this as your component tree for our application, right? We have the app, the info card, and the footer. We can invoke the template function in creation mode to create the app component. Then we can invoke the template function for the info card to create the info card component, and then do the same for the footer. So really, if we want to create an entire application, or the DOM for an entire application, all we have to do is call all of these template functions in our component tree. So what is a template function? A template function is a function that is composed of a number of instructions. And when I say instruction, what I mean is it's like it's a function that is implemented by the Angular framework that does some specialized piece of work. So you can roughly divide them into two camps. There's creation instructions, which you may have guessed, they create things. And usually it's indicated by the name. So the element instruction creates an element, text instruction creates a text node, the projection instruction creates an ng content. You can kind of guess where this is going. And the update instructions will take an existing element or component or something, and it will update it. So the property instruction updates a property, the attribute instruction updates an attribute. Once again, it's pretty self-explanatory in the name. And what instructions are actually generated in your template function depend on what you've actually put in your HTML template that you've written. So if we go to the app components template here that we were just looking at, the compiler would generate something like this equivalent template function. And right now, we're just kind of focused on the top part, right, because we're in creation mode. So let's start by explaining how all of this works. So the first thing I want to draw your attention to is that the structure of your template function is really mirroring the structure of your HTML template. You see that we have an image tag on the right, has a source attribute. And then in the element instruction, we're passing in that tag name for image. We're passing in the source attribute. So they're really similar. And we do that on purpose so that it's easy for us to create the exact DOM that you wrote in your template. Because we're not actually just taking the template string. It's not HTML. We're not just inner HTMLing it. We're actually creating all of these elements one by one, which is what these instructions do. So if we took a closer look at the element instruction, we would take the tag name that you give us, and we use really recognizable DOM APIs that you've probably used before, like document.createElement, pass in the tag name, get whatever parent is the right one for right now, which would be the root element in this case, set any attributes that you set, and then just append the element that we just created to its parent. So it's all much more straightforward than I think you might expect from what's inside this function. We also do one more thing, and that's we track all of the elements as we're creating them. So we store them in our own internal data array. And the reason that we do this is because later in change detection, we're going to be updating these elements, right? And so we're going to need some way to get access to them. So we could use DOM APIs, right, like query selector to get a hold of them, but that can be pretty expensive and pretty slow. So instead, we have our own way of keeping track of these elements so that it's fast for us to access them later. The internal data array where we store these elements is something that we call an L view. It's also known as a logical view. And we create an L view instance for every template instance or every component instance. So every component has its own set of storage that has its DOM elements inside it. So in addition to DOM elements, we also put things like binding values in here, so we can check old binding values against new binding values. We also put directive instances in here so that we can set inputs on them later. So yeah, every component has its own source of data. And so for creation mode, what we're doing is we're going through and we're adding each element as you create it into this array. So if we go back to our template and we imagine that we're executing it line by line, we'll create this image tag, we append it in the correct place, and then we'll store it in our L view here on the bottom right. Then we'll create the H1, we'll append it, we'll store it in our L view. We'll do the same for the info card and the footer. There's one more thing that these element and text, or really just element instructions are doing, and that's directive matching. So at compile time, the compiler will analyze your ng modules and your component decorator, and it'll figure out, based on your ng modules, what directives and components are available to your component in its module scope. And once it knows what all those directives are, it'll print out that list of directives inside the component definition. So here for the app component, it has access to the info card directive or component and the footer component. And this makes it much easier for us because at runtime, the runtime doesn't have to worry about module scope or any of that stuff. We know what our list of available directives is from the component definition. So if I put the registry up here on the right so you can kind of visualize it, as we're creating all of these elements, we're also matching directives against the elements that we're creating. So for this image tag, we'll look at the registry, look at the first item, which is info card. We'll grab its definition, look at its selector, right? And then we'll try to see if the image tag matches the info card selector. They don't match, so we'll keep looking, checking to see if the image tag matches the footer selector. Still won't match. And we'll keep going through as we're creating until we actually get a match. And at this point, we need to actually instantiate the directive or component that we found. So your first thought might be, oh, the framework should just call new on whatever type it is, and then you're done. But that doesn't really take into account dependency injection. Any of these components or directives could have any number of parameters that could be anywhere in the tree. And so what we do is we instead call the components factory. And this is the same factory function that we invoked at the very beginning. So if you look at what InfoCard's factory function would look like, it'll call new on InfoCard, as you might expect. But it also has this directive inject instruction. And this is the instruction that powers dependency injection. So this is the thing that's actually going to go get this info token that you've asked for. And dependency injection is kind of its own talk, but the gist of it is that the directive inject instruction will take the token, and it will first check the directive injector tree. The directive injector is where we keep track of all of those providers that you added on directive definitions and component definitions, as well as the directives and components themselves. So every time you have a node that has directives on it, we create a directive injector. So it becomes this, this big tree of directive injectors as you walk up kind of the DOM. So we'll look at, the directive injector for the node that's closest to where we're requesting it, and then we'll keep walking up all the way to root. And if it's not there, then we fall back to the module injector. The module injector is where we keep track of providers that you set on ng modules. And if we don't find it in the module injector, then you're out of luck, and we'll return null or something, depending on if it's optional. OK, so for this info service provider in our example app, let's say that we provided it on the app module. So when we're creating the info card, we call directive inject, and directive inject will first check the node that we're currently on. So it'll check the info card node. And it'll try to see, OK, is there a directive injector here, yes or no? Is there a directive that's registering info service as a provider? No, there isn't. So then we'll move up to the next parent element that has a directive injector, which is going to be the app root element, which the app component is on. Did the app component provide info service? No, it didn't. So that's when we fall back to the module injector, take a look to see if it's been provided, and it has, so we're very happy. And we can correctly create the info card directive with the info card service, or I think it's just called info. So as soon as we create the info card instance, we're going to want to save it in that same LView array And like I mentioned earlier, we need to keep track of directive instances so that we can set inputs on them later, and also so that we can call lifecycle hooks with the correct context. There's a lot of things we do with directives, so we have to keep track of them. Then, of course, since you can compose multiple directives on the same node, we'll also check the rest of the directives in the registry after that. So we'll also match the footer later and add it to the same array. So one thing that you might be thinking is, this directive matching process seems super expensive. Your directive registry is probably more than 2 directives, right? It's normally most of common module, right? You've got ngIf, ng4, you have all your imported modules, you might have material, and that's very true. And so directive matching is not something that we want to do more than once per component. We want to do it the very first time we see a component, and then we never want to do it again. So how do we make that work? Well, essentially, we make that work through shared data structures. So I've already mentioned the L view and how we create one per component instance. We also have a T view or a template view, and we create one of these per template function or per component type, depending on how you want to think about it. So for example, if you have a component that has 10 instances, you would create 10 L views and 1 T view, and all of the instances would share the T view. And the way that we make this work is that we store the T view on the component def. So the next time we create this component instance, we can look at the def, look up the T view, and look at all the information that we stored the first time around and make use of that. So in practice, it might be something like this. We have all of our elements in our L view. We have our directive instances. And as we're pushing directive instances into the L view, we're also pushing their definitions into the T view at the same index. Similarly, as we're creating DOM elements, we're also pushing template nodes into the T view at the same index. And template nodes, or T nodes, are essentially just kind of metadata about each DOM element. So it'll contain information like the tag name, or more importantly in this case, information about directive matching. So on the T node, we'll have a list of directive indices or a range of directive indices that match this node. So for info card, for example, the second time we go through this app component template, we'll get to the info card element. We'll check to see if there's a T node at that instance that we already created. The T node will have information about where the directives are stored for this node, and it'll point to the definition. And then we can just go ahead and instantiate it immediately without having to do any matching. So that makes it really quick for subsequent component instances. OK, so that pretty much takes us through view creation for a single component. But as we mentioned, we're going to be doing this for every single component. So just imagine the same process for info card and footer. Which brings us to change detection. Change detection, once again, is the process where we check all of our binding values, and if they've changed, we re-render the view to reflect the updated values. As you may have guessed, it's very similar to view creation in that we can just go ahead and invoke all the template functions down the component tree, but instead of using the creation flag, this time we can just use the update flag. So if you call all these template functions top to bottom, then that's change detection, essentially. So now we're going to focus on this second half of the template function now that we've explained the first half. And this is what we'll execute when you're in update mode. So again, the first thing I want to draw attention to is how similar these two things are. If you have your template on the right and your template function on the left, there's the header binding. You can see that in both places. And below that, there's the name binding. You kind of see them one-to-one. However, we're no longer creating elements, right? So we're not necessarily going to have a one-to-one mapping for every element. There'll be some elements that have multiple bindings. There'll be some elements that have no bindings. So to keep track of which element we're on when we're generating our binding instructions, we also have these advanced instructions. And these kind of tell us how to negotiate between nodes and bindings. So this is much easier to visualize if you kind of can see the data structures. So on the right here, imagine this is the L view. This is the array where we've been storing our elements. And these 0 through 6 are the indexes or indices of the L view. And we're going to need to keep track of two things. One is the current node. So this is the node that we are currently on, the node that we actually want to update the properties for. And then there's the current binding. The current binding keeps track of where we are in the L view. That's a better way to explain that. So basically, we need to keep track of all of the old values of bindings so that every time you run change detection, we can tell whether it's changed, right? So the old binding values we will save in this section of the array after the DOM elements. We'll have kind of a counter that keeps track of where we are in that section of the array as well. And you'll see how that works in a second. OK, so let's say we execute the first advanced instruction. All this does is tell us that the first binding is 2 nodes down. So it'll say, hey, increment the current node counter until you get to the node that's 2 nodes below wherever I am. So now we're on the text node. And then we run the text interpolate instruction. And all this does basically is it checks the header variable that you passed in, so context.header, against whatever value you have at the current binding index, which is right now, it's empty. So the first time, we just assume that the values have changed. So we're just going to go ahead and update that text binding in the DOM. And we'll also cache the value for the next time that we run change detection. And then we'll increment it so we don't keep overwriting the same value. So we're done with bindings on the current node, right? So we advance 1. And that tells the framework that the next binding is on a node 1 slot down, which takes us to the info card. And then we execute the property binding instruction. And that says, hey, for whatever node you're on right now, you want to check the name property and use the value that I'm passing in, so the name value. And again, it's the first time, so we assume it's changed. So we'll want to update the binding value here. But you'll notice that this is a directive input, right? This is not an element. So we don't want to go and set the name property on the element. We want to set it on the info card component. But you'll remember that we have this beautiful mapping between a certain node and all the directives on the node. So it's pretty simple for us to extrapolate which component this is and set the inputs on it directly from there. So the next time that you go through change detection, we'll be checking against these values that we just saved. So whatever the new value of header is, we'll be checking it against Hermes the cat. And then whatever the new value of name is, we'll be checking against Sherlock Holmes. OK, so one thing that you might have noticed is that change detection is going to be running within a view from top to bottom, right? Because we're keeping the ordering as we mirror the template. The component tree is checked from top to bottom, and all the nodes within a component view are also checked from top to bottom. So it's pretty predictable. So if you had this template, with the div and the text binding, 1, 2, 3, 4, you can expect that it's just going to be executed in the same order that you see, 1, 2, 3, 4. That's the order that the bindings will actually be set. Before Ivy, in View Engine, this was actually slightly different. I don't know if you guys can guess what the order would be right now. Just think about it in your head. OK. Is this what you thought? 3, 4, 1, 2? OK. So the reason for this is that pre-Ivy, we would do 2 separate passes. We'd do one full pass for directive inputs, and then another full pass for element and text bindings. So in practice, it makes sense from an implementation standpoint, but from a user perspective, that's super confusing, right? You wouldn't expect it to happen in a different order than you see. So that's one thing that we've fixed in Ivy, is we've made it a lot more predictable how your template function is actually going to run, or how your template's going to be checked. But one thing I want to call out is that while we would guarantee the binding order between nodes, we don't guarantee binding order within a particular node. And there's a really good reason for this, and it's essentially to reserve the right to optimize bindings within a node. So for example, let's say we have this component, has a bunch of property bindings, has a bunch of attribute bindings. We could just generate something like this in your template function, right, where we have an instruction for every binding in the same order that you wrote it, just like as you might expect. However, it's pretty duplicative, right? You have 2 property instructions, you have 2 attribute instructions. Is there any way that we could optimize this? And we can, using property chaining. So if we can kind of fudge the order a little bit within a node and move them around, we can take the property binding from below, and we can chain it on the property binding at the top. And we can do this because the property instruction returns itself. So the function is returning an instance of itself. And so we can keep chaining properties and attributes and save those extra function function names in the code size. So this might seem like a micro-optimization, and it is, but over large templates, it actually makes a big difference. So this is the kind of thing that we like to do. OK. Oh, yes, I have time. OK, so one thing I haven't talked about yet is lifecycle hooks. You might be wondering, when do these happen? And they actually execute as part of change detection. I just kind of omitted it for simplicity. But now we're going to go back and kind of enrich what we had before. So you are probably familiar with lifecycle hooks, but I'll do a quick review. So the first three, ng on changes, ng on init, and ng do check, these are all hooks that have to run after the inputs are set for a particular directive. After view init and after view checked usually happen after the view, or always happen after the view is checked. And then after content init and after content checked happen after content children are checked. But what you may not know is that they actually execute slightly differently. So these first three hooks, we execute node by node. So we'll run them like one node at a time. Whereas the other ones, we run view by view. So we'll run all of them at once for a view instead of all of them at once for just a particular node. And what that means is that all of the node by node ones, the on changes, the on init, and do check, we have to actually run while we're executing the template function, because that's when we're actually evaluating the nodes. So if we go back through this lovely process, all the lifecycle hooks are being executed in this advanced instruction. So in addition to changing the cursor for the current node, we're also executing lifecycle hooks. So here, as soon as the advanced instruction runs, we know that we're done with all of the inputs and all of the bindings for that node, right? That's how we know that we can advance. So for this one, in advance, we would say, hey, there's no more bindings for node 0 or node 1. That's why we're moving. So we can execute all the lifecycle hooks for node 0 and 1. So then we move the cursor like we did before. We check the binding for the text binding, update the value like we did before. And then we get to the next advanced instruction. And at this point, we're done with all of the bindings for the text node. Obviously, this doesn't work. We're not going to have any lifecycle hooks for the text node. But if this had been like a normal element, this is where we would flush any lifecycle hooks for that node. So let me check the last instruction. And then at the end, there's no more advanced instructions because we're done, right? So after the template function is invoked, we just execute any of the lifecycle hooks that remain for things that don't have bindings. So after the template function runs, we actually do a few more things. One thing is that we refresh your embedded views. These are all of your ng templates that have been added through something like ngIf or ng4. I really wanted to talk about that today, but I don't have time. Come find me. Then we flush all the content hooks. So remember I said content hooks and view hooks happen node by node, or happen view by view. So this is where we flush all the content hooks at once for a particular view. We set host bindings. We check any of your child components. So once again, we're calling the template function for any of the child components in the tree. And afterwards is when we flush all of the view hooks. And view hooks are bottom up, so we have to check the child components first. So hopefully by now you have a better understanding of what you're seeing here, right? We've kind of gone through all of these instructions. So hopefully this isn't as scary. Just as like a quick review of what we've seen. In view creation, we created some elements. We set up some attributes. We didn't have any listeners, but that's where we would have registered them. We matched directives. We instantiated directives. We performed DI. We created our child components. In change detection, we checked all of our bindings. We called lifecycle hooks. We refreshed embedded views. We checked our host bindings. And we checked our child components. So there's a lot going on. But hopefully that's a little bit more digestible than it was before. Thanks.